Hello everyone, continuing from the last class, we were doing calculation for excavation in artwork. So in doing so, uh, we calculated for the steps and sidewall, and then we saw that there is already a column by the side of these steps, and for that column we have done the calculation for footing part. So we have to deduct some portion which we are calculating twice while doing calculation for the steps. So this is the diagram for our understanding. There is this column, then there are steps, and there is this sidewall. Now this portion we are calculating twice, once with the steps and sidewalls and once with the footing of the column. So we have to subtract one part. Now, what are the dimensions that we have calculated twice? From the center line of the column, we see that on one side there is 0.45 meter and on the other side 0.45 meter. Why? Because the footing is 0.9 meter by 0.9 meter. Therefore, on one side it will be 0.45 meter, no doubt. On the other side, how much is the length? From the center line, we see that the sidewall is 30 centimeter thick and the column is 20 centimeter by 20 centimeter of dimension. So one part will be 10 centimeter, one part will be 10 centimeter. This extra part of the sidewall is 10 centimeter, and then we are providing 10 centimeter extra. So from the center line of the column, the length will be on one side 0.45 meter, on the other side 10 centimeter plus 10 centimeter plus 10 centimeter, 30 centimeter. So this is our length. 0.45 meter plus 0.3 meter, 0.75 meter. And then we see the breadth. The breadth from the center line of the column is obviously going to be 0.45 meter. That is the size of the footing. Okay, on one side 0.45 meter, on the other side 0.45 meter. Then we see that the steps are starting from the side of the column. Okay, from here. Therefore, we have to subtract half of the size of the column from 0.45 meter. So 0.45 meter minus 0.1, it becomes 0.35 meter. So deductions we are doing, 0.75 meter is the length, 0.35 meter is the breadth, and 0.17 meter is the height that we see from the sectional elevation. So this is 10 centimeter and this is 7 centimeter. So we calculate the volume and subtract this volume from the already calculated work, and we get the net artwork. Then we have to calculate for artwork in filling in the plinth. We see that from the sectional drawing, we see that we have art filling here, then we have sand filling, then we have 7.5 centimeter line concreting, and then we have 2.5 centimeter cement concreting. This dimension is given to us up to the ground level as 60 centimeter. So from the 60 centimeter, we will subtract 2.5 centimeter for cement concreting, 7.5 centimeter for line concreting, and 15 centimeter for sand filling. Then we are left with 35 centimeter of art filling work. Now this art filling work will be done here. From the plinth beam to the plinth beam. The plinth beam are at the edges. Okay, the plinth beams are here. Okay, below the walls. So inside the plinth beam, we have to do art filling work. For this living room, this 3.7 meter by 3.7 meter by 5.5 meter. This should be meter. So for the living room, that is the dimension. Then for the kitchen, it is 2.1 meter by 3.7 meter is the dimension of the kitchen. But we see that here, this is a half wall, 10 centimeter thick, and the plinth is 20 centimeter thick. Therefore, we have to subtract half of 20 centimeter from this 2.1 meter. Okay, along this direction, it is 2.1 meter up to the wall, but up to the plinth, how much will be the dimension? 2.1 meter minus 10 centimeter, it is 2 meter, and in this direction it is going to be 3.7 meter. Then in the veranda, This is how much? 1.7 meter up to the wall, but up to the plinth it will be 1.7 minus 10 centimeter. Here this much portion, half of the plinth beam size. So 1.6 meter by 2 meter. So these are the area of earth filling. The thickness or height or depth of the earth filling work remaining same in all cases. Okay, so for the living room, 3.7 meter by 5.5 meter, 0.35 meter is the height. This is the value. For the kitchen similarly, for the veranda similarly. So then we get the total volume of earth filling. Then there was sand filling. The dimension will be exactly same except the height. Other things are same. The height is, we saw from the sectional drawing, that is 15 centimeter. So we are taking all the dimensions and getting the volume, and then finally we are adding to get the total volume of work. Then there was cement concreting in the foundation below the column. Okay, below each column, 10 centimeter thick cement concreting was done. So 90 centimeter by 90 centimeter or 0.9 meter by 0.9 meter is the size of the column, and this is the depth. This is the total volume of cement concreting below the footing. And then in the steps and side walls, okay, in the steps and side walls, 1.6 meter, 0.8 meter and 0.07 meter, we see that from our this diagram. Okay, this diagram, this is the cement concreting below the steps. 7 centimeter is the height, 80 centimeter is the breadth, and what will be the length? The length will come from here. The 1 meter for the steps, 30 centimeter and 30 centimeter for the side wall. So 1 meter plus 0.3 meter plus 0.3 meter, it becomes 1.6 meter. So we do the cement concreting work at the footing. Then RCC work. Now RCC work at the footing and RCC work at all other location we have to do. And in the footing there was 9 column, 9 footing, size 90 centimeter by 90 centimeter. What is the height or depth for the rectangular portion or square portion? And then there is another trapezoidal portion. If we go back to the sectional elevation, we see here that this is the footing part, and in this footing part there is one square portion and one is trapezoidal portion. So we have to calculate it separately for simplicity. The square portion is very easy. Okay, area multiplied by height, and then we have to use one formula for the trapezoidal portion. We come back to our calculation. This is our calculation. Okay, 90 centimeter by 90 centimeter, 15 centimeter is the height for the square portion. We get the volume. For the trapezoidal portion, we use this formula, h by 3 a1 a2 and root over a1 into a2. Okay, this formula is to be used. Now what is a1 and a2 in this formula? Okay, this is the formula. So this is the trapezoidal footing, for example. This is, if it is a trapezoidal footing, the lower part we are saying A1 area, the cross-sectional area at bottom is A1, the cross-sectional area at top is A2. And height is denoted by H. So we put it in this formula, 1 by 3 into A1 plus A2 plus root over A1, A2 into H. So we go back. So we are using that formula. Height is 0.3 meter. A1 cross-sectional area at the bottom will be 0.9 meter into 0.9 meter, and cross-sectional area at the top will be 0.3 meter by 0.3 meter. It is shown here. It is shown here that this is 30 centimeter square here, and this is obviously 90 centimeter by 90 centimeter. So using this formula, we calculate the volume of the trapezoidal portion, and then we add them up.